Good day, guys. So one thing that appears on AP exams every once in a while is they will ask you to use a Taylor series or a power series to do other tasks such as approximately find the value of definite integrals or limits. Today we're going to try this with integrals. So I have a definite integral here that we want to evaluate or at least approximate, and it's one that I don't think we have any tools that we've learned to find the exact value of it. We don't know the antiderivative of e to the x squared, but we're going to estimate the value by easily writing e to the x squared as a power series, or in this case, actually as a Taylor polynomial with four terms, and the first four terms substituted for this expression will give us an easy approximation. So let's get started. I've already pre-started it by noting what we're going to use is our notion that e to the x has a power series 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. Remember, the general term is x to the k over k factorial. That's one that we're supposed to be getting familiar with. So the substitutions are going to be made for x squared going in for x. And the power series for e to the x squared will then become 1 plus x squared plus x squared squared, or x to the fourth, over 2 factorial. And then the fourth term will be x squared all cubed, or x to the sixth over 3 factorial. And I've gone ahead and written the next term too, but we're only going to use the first four. So basically our integral that we want to try to estimate, e to the x squared dx from 0 to 1, your approximation is going to come by integrating the first four terms of the Taylor polynomial. And I'm going to write those in there. And I'm going to go ahead and write out what the factorials are also. So 2 factorial is still 2, and 3 factorial is actually 6. So here is our new integral that we're going to solve, and this one's much easier because it is a polynomial. The antiderivative is just found with the power rule, and I'm going to write that out. This one will be x to the fifth divided by 10, and this one's going to bump up to x to the 7, and then on the denominator will be 6 times 7, or 42, and we're only going to have you use the first four non-zero terms, and this is them. And it's going to go 0 to 1. Plugging in the 1 is going to give us a series of fractions, and plugging in 0 is going to give us all zeros. So my final approximation is whatever these fractions add up to. Now, if this were on an AP test, free response section, you'd be just well advised to leave this alone. This could be your answer. If you do want to take the time to add them together with your calculator or what have you, you could do that too. But hopefully this will get you started today. You're going to work on about 3 or 4 similar problems. The notion is take the integrand and use your understanding of some of those important Taylor series that you've been learning. Making substitutions into those, you can create a power series for the integrand and then integrate it easily because you're treating it like what it is, a polynomial, and to get your approximation that way. Hope this helps you guys. Let me know if you need any other help or have any questions later on today. Thank you.